Hello students, welcome to Sri Jayendra's Ring Zone classes. I am your friend and mentor for coming classes with respect to physics. This is lecture number 7 of a unit waves. So let's begin with today's class. In today's class we are going to discuss about the Doppler effect. So let's see what Doppler effect is. So when we say Doppler effect, it is the phenomenon of apparent change. It is the phenomenon of apparent change in the frequency of the source of the sound due to the relative motion. Please remember this word, due to the relative motion between the source and the observer is defined as the Doppler effect. And we have one more term, that is what we call as a Doppler shift. So basically Doppler shift is change in the frequency, when I say change in the frequency and the apparent frequency of sound heard, that is what we call as the Doppler shift. So it is basically the difference of the original frequency and the apparent frequency. That is what we call as the Doppler shift. I hope this is clear. Now, what is the formula? Because we are not going to go in the derivation. I hope you have been gone through the formulas and derivation of it in your school classes. So we directly go through the formula of this. That is the f dash is equals to f naught into bracket v plus minus v naught upon v plus minus vs. The f dash, it is the apparent frequency. It is the apparent frequency. F naught, it is the original frequency. V, it's a velocity of sound wave. V naught, it is the velocity of observer, and Vs, it is the velocity of source. So please keep this noted. Please note this. Do it quickly. Have you noted it? Have you? Have you noted it? Great. So now let's take a different cases, and that are only the numericals of this Doppler effects. So let's have a look. Let's suppose I have been given that source, this one is the observer. Observer is at rest and the source is moving. The velocity of the source is Vs, as well as the sound wave is moving in this direction, because then only you are going to listen what source is speaking. So this is V, and let's suppose the original frequency is f naught. I want to find out the f dash. This is the requirement. So what we are supposed to do is, this is our standard relation. This is f dash is equals to f naught into bracket v plus minus v naught upon v plus minus vs. Yes, this is the situation. This f dash is equals to f naught into bracket v plus minus v naught upon v plus minus vs. When I say this is v plus minus v naught or v plus minus vs, then the situation will be equals to that. First, observer is at rest, that means v naught is 0, and the rest of the terms I need to write. It's an f dash is equals to f naught into bracket v upon, as I understand that this is the relative motion. So v is there, vs is there. This direction of motion of v and vs both are same, so I will write it with subtractive term. This is the final answer. F dash is equals to f naught into bracket v upon v minus vs. I hope this is clear. Is it? Great. Let's look at the next. It says this is source and this is the observer. Now let's suppose source is at rest, observer is moving in this direction. This is v naught, as source will speak, this is the velocity of the sound wave. Original frequency is f naught. We are interested in f dash. How will we do this? First, write down the standard formula. This is equals to f naught into bracket v plus minus v naught upon v plus minus vs. I hope this is clear. So now let's write it for our case. They have given source is at rest, so this is f naught into bracket. This will be the v only. Now I need to consider this both because even observer is in motion and v would be always there. So if it is the situation, then this direction of motion of v, which is the velocity of sound wave, and direction of motion of the observer, both are in the opposite direction. And if they are in opposite direction, I need to write this. This is f dash is equals to f naught into bracket v plus v naught divided by v. This is the final answer. I hope this is clear. Is it clear? Is it? Are you sure? Great. Let's work for the next case, that this is the source and this is the observer. Let's say source is moving in this direction with a speed of vs. Observer is moving in this direction with a speed of v naught, and it is for obvious that so sound wave will be moving in this direction. Then only you are able to receive this. I hope this is clear. So how will we do this? If original frequency is f naught, find out the f dash. This is the question. So if I write down the standard formula, it's an f naught into bracket v plus minus v naught divided by v plus minus vs, and I need to find out the f dash. So to find out the f dash, I need to do it's an f naught into bracket. This is the motion of sound wave, this is the motion of observer, and both are in the same direction, so I need to write this. It's a v minus v naught divide by, this is the motion of sound wave, this is the motion of the source. So both are moving in the same direction, and if this both are moving in the same direction, I should write this. It's v minus v naught upon v minus vs. Have you got this? Have you? Great. Ready for next question? Let's have a look. Let's suppose this is the source and this is the observer. Both are moving towards each other. That means it is in this direction and it is in this direction. And the sound wave, it is moving in this direction. If original frequency is f naught, f dash is required. So if I write down the standard formula, it's a v plus minus v naught divided by v plus minus vs. This could be sorry, this could be written as this is equals to f naught upon multiplied by, this is the velocity of wave, this is the velocity of observer, as both are moving in the same direction. So this can be given as opposite direction. So this is v plus v naught divided by, this is v, this is vs, and as both are moving in the same direction, so this could be given as v minus of vs. This is the apparent frequency. You can easily put out the value and calculate the data. Yes, great. Now let's look at the certain questions. That let's suppose this is the source, this is the observer. The source is moving in this direction with 30 meters per second. This observer is moving in the same direction with a speed of 30 meters per second. The sound wave, a data not given, but it is having a speed of v. If original frequency f naught is, let's suppose it's 200 hertz, we want to find out the f dash. So let's write down the formula and work for it. It's an f dash which is equals to f naught into bracket v plus minus v naught divided by v plus minus vs. This will be the situation. So if this is the situation, what I need to do is this f dash is equals to f naught into bracket this v, and this is the velocity of the source vs, this is the velocity of the observer. So v and v naught both are moving in the same direction, it's a v minus of v naught, divide by this v and vs both are moving in the same direction, it's a v minus vs. This would be the formula. Let's get the data in the formula. It's an f dash is equals to f naught, which is equals to 200. This is equals to v minus v naught, which is 30, divide by v minus v source, it's a v minus of 30. So as this was cancelled, and this f dash is equals to 200 hertz. So this is original frequency, this is the same frequency. Why this happened? What do you think? Why this has happened? Yes, this is the case of no Doppler effect. But why no Doppler if has been happened? Because as you can see this, that both source and observer are moving on same direction with same speed. So there is no relative motion between source and observer, so that as there is no relative motion between source and observer, so the apparent frequency is equals to original frequency. Yes, so the apparent frequency and original frequency will be the same because there is no relative motion, and this is the first case of no Doppler effect. I hope this is clear. But if reverse is the case, let's understood the situation that this is the source, this is the observer, this is moving in this direction with speed of 30 meter per second, this is moving in this direction with speed 30 meter per second, and let's call this as a 300 meter per second. This is velocity of sound wave. The original frequency is 200 hertz, and I have been asked to find out the f dash. Then I can write f dash is equals to f naught into bracket v plus minus v naught divided by v plus minus vs, and this will be the case. Then this is 200 divided by, this is the observer which is moving in the opposite direction to the velocity of the wave, so it's a v plus v naught divided by, this two are moving in the same direction, so this is equals to v minus of vs. So this is equals to 200 into bracket, this is 300 plus 30 divided by 300 minus of 30. So this tends to 200 into 300 plus 30, it's a 330. 300 minus 30, it's a 270. So this has gone, this has gone, and this is equals to, this is 11 threes are, this is 9 threes are, so it's a 2200 divided by 9 hertz. So there is a, because in this situation both are moving towards each other, and every second their separation is keep on changing. In this previous case, as they are moving in the same direction, so their separation remains the same, and if their separation remains the same, it means no relative motion. I hope you understand the difference between this two. So if no relative displacement occur, there are no chances that the Doppler effect can occur. I hope you understand this. And if no Doppler effect, that means apparent frequency and the original frequency will be the same. I hope you understand this. Have you? Do you understand this? Are you sure? Completely. Do you have any doubts up till now? Is there anything? Is there no? Are you sure? Great. So let's work for the next question. Suppose the next question is that, let's suppose this is the source and this is the observer. If this is the source, this is the observer, then this source is moving in this direction, observer is moving in this direction, and this is, let's say, with speed vs, and this is with speed vo, and it is obvious that sound wave should move in this direction, because then only as an observer you are going to receive this wave. So original frequency is f0. You want to listen about the f dash. How will you do this? So this f dash is equals to f0 into bracket v plus minus v0 divided by v plus minus vs. This is the situation. This is f dash, which is equals to f0 into bracket v plus minus v0 upon v plus minus vs. And when this is the situation, this will be equals to, this is v plus minus v0. That means this is v minus of v0 divide by, as both the directions are opposite, it's a v plus vs. I hope this is clear. Was it clear? Was it? So can you do this kind of questions? Yes? Great. Now let's suppose the different situation is there and it is a circle, and here is the source which is at rest, and you are the observer and you are moving on this circle with speed v0. This is a circle of radius r. If original frequency is f0, find out apparent frequency f dash. So this is the requirement. If original frequency is f0, you need to find out the apparent frequency, and that apparent frequency will be the f dash. How will you do this? How will you do this? Or what could be done? What do you think? What do you think? So let's have a look at the situation that original frequency is f0 and I want to find out f dash. If you see this, there is no relative displacement between observer and source. So there is no relative displacement between observer and source, and if there is no relative displacement between observer and source, that meant f dash would be equals to f0. I hope this is clear. Okay, let's take a second case in which the situation is slightly reversed. That this is the situation that, let's say, observer is standing over here. He is the observer which is at rest, and this one is the source which producing a sound wave with f0. It is moving in this direction with speed of v0. So again you need to find out the f dash. So again as you can see, this is the distance, or would be a radius only. So every time it is moving every time it is moving with same speed. First thing. Second thing, the separation between source and observer remains the f naught only, radius r only. So if the separation between the source and observer is the same, that means f dash would be equals to f naught, and these are the cases. These are the cases of no Doppler effect. I hope you understand this. These are the cases of no Doppler effect. Did you understand this? Have you? Have you got this? Are you sure? Now, do you have any doubts? Is there anything? Is there anything? Anything? No? Great. So this is the case. This is the cases of no Doppler effect. Are you done with this? Do you have any doubts up till now? Do you? Do you have any doubts? Are you sure? Are you sure? Great and well done. So now let's move to the next. Let's suppose the situation is that this is the road, and one of the car is being passed through this road, and it is moving with speed vs, and observer is here, which is at distance of something like this. This is the angle theta, and it is at rest. So if at this instant this car is producing a horn having a frequency of f naught, what will be the frequency of the f dash that is heard by the observer, which is at rest? So how will we do this? So basically the situation is that this car is moving in this direction. So if I make a component of its motion in this direction, in a direction of the observer, it is vs cos theta. And what would be the direction of sound wave? It is in this direction only. And you do not need to make any time component of this sound wave, because when we produce a certain sound, it will go in the every direction. I hope you understand this. And when the sound wave is going in every direction, you just not make a component of any waves. I hope this is clear. So please do not make any time component of the waves, or I should say sound wave, but you need to make a component of velocity of source, or let's say if it would be possible then velocity of the observer, because they are not physically moving in every direction. So you need to choose a component. I hope you understand this. Great. So now let's write down the master formula first, which is equals to f naught into bracket f dash is equals to f naught into bracket v plus minus v naught divide by v plus minus vs. This is the situation. This is f dash, which is equals to f naught into bracket v plus minus v naught upon v plus minus vs, and this is simply equals to the f naught into bracket v plus minus v naught. While I write this is v plus minus v naught, then observer is at rest, so this is equals to v divide by this is v plus minus vs, so this is equals to v minus vs cos theta. This is the apparent frequency that we received. I hope this is clear. Would you like to have one more question? Now with certain little greater complications, let's have a look. That this is the crossroads, and one car is moving over here and another car is moving over here. You are sitting over here and you are the observer, and this car is moving with speed v1. This is the source of the sound wave, and this is f naught, and it is moving in this direction v2. If we connect these two lines, then let's say this is angle theta 1, this is angle theta 2. So if this is the sound that has been produced by the source with frequency of f naught, what will you going to heard is the question. How will we do this? What could be done? So we need to make a components of the motion of the source, motion of the observer, but not with the motion of the sound wave. So as this one is the v1, this one should be v1 cos theta 1. As this one is the v2, this one should be v2 cos theta 2. And this is the source, and this sound wave is moving in this direction because the source has produced it, and its speed, let's say v. So if I want to write down the Doppler effect, then it should be f dash is equals to f naught into bracket v plus minus v naught divided by v plus minus vs. This will be the effect. Now when I write this is an f naught into bracket v plus minus v naught upon v plus minus v net, this is equals to f naught into bracket, this is v naught. When I say it's an observer, it's a v, this is v1 cos theta 1, so this is v plus v1 cos theta 1 divide by, this is v, this is vs, so this is equals to v minus v2 cos theta 2. I hope this is clear. This is the f dash. Does it clear? Does it? Are you sure? Do you have any doubts? Do you have any doubts? Is there anything? Is there? Are you sure? Any doubts? Is there? No? Great. So this is the situation. This is the situation. And this is how you can find out the f dash. I hope this is clear. Great. One more question. Let's have a look. The question says that this is the circle. Let me redraw it. Yes, this is the circle. And you as an observer, you are sitting over here. When I say it's a sitting, it's a rest. And this is the center. This is the radius r, and he is the observer, he is the source, which is moving in this direction. It's vs. So let's mark the 4 points. It's an a, it's a b, it's a c, and it's a d. And let's say this distance is the x. So they can ask that if the source produces a frequency of f naught, find out at which point, you will receive maximum frequency and minimum frequency. So they ask us that at which point we are about to receive the maximum frequency, and at which point we are about to receive the minimum frequency. How will we do this? So let's understood the situation for the different cases. That first, let's look at this. This is the VB, and if it is the case of the VB, it's a motion in this direction. This is the velocity of the source, and this is the velocity of wave as it is at rest. Same way for VD, it is the motion in this direction. Velocity of wave would be in this direction. So for VB equals to VD, this is equals to F naught into bracket. It would be an observer. It is at rest, so I write this. It's a V, and this is equals to V plus minus. It's a Vs cos 90 degree because these are perpendicular with each other. And if these two are the perpendicular with each other, then at point VB or VD, I'm talking about this F dash. Let me rewrite this. This is F dash at VB or VT. Yes. So this is equals to F naught into bracket V Vs cos 90, it's a 0, this is V, so this is equals to F naught. Yes, so this two locations VB and VT, so at B and D, no Doppler effect is possible. Yes, so these two are the locations, where no Doppler effect will be available. I hope this is clear. Is it clear? So at B and D, no Doppler effect is possible, and these are the locations where you are going to hurt the same frequency as the source picks. Is it clear up till now? Is it? Are you sure? Are you? Great. So these are the locations B and D. This will happen. Next, the next situation is, let's talk about the VA and VC. So let's suppose this is the A, this was the C, and here an observer is there. So when I say he will move like this, it's a velocity of source. Then this is the velocity of wave. It's a velocity of sound wave technically. So F at A would be equals to F naught into bracket. This is V upon V plus Vs. When I say this is C, it is moving in this direction. This is velocity of source. Even this will be the velocity of wave. And if both are moving in the same direction, then this is equals to Fc is equals to F naught into bracket V upon V minus of Vs. I hope this is clear. So from Fa, apparent frequency at location A, and apparent frequency at location C, that you observe that apparent frequency is minimum at point A, and it is maximum at point C. I hope this is clear. Is it clear? Is it? Great. Now let's do one of the question based on the bits and the Doppler effect. Let's suppose this is the source 1, and now this time I am having two sources. This is the source 2. The both are going to produce a sound of frequency F naught, and this one is the observer, which is moving in this direction with speed of V naught. Yes, the question is find out bits frequency heard by an observer. This is at rest, even this will be at rest. How will you do this? What is to be done? What do you think? You need to find out the bits frequency heard by an observer. So basically what happens, that whatever the frequency F naught this will speak, you will heard F dash, or I should say, let's say F1 dash for this source, and you are going to receive F2 dash for this source. So first task would be to find out the F1 dash and F2 dash, and then we can take a difference of this and find out the bits frequency that is heard by the observer. So if I find out the F1 dash, let me do this here only. This is F1 dash is equals to F naught into bracket, as this sound wave will be in this direction, and this V and V naught both are in opposite direction, so I should write it's a V plus V naught. As source is at rest, this is V. Same way for this sound wave is moving in this direction, this is V. So for this it's an F2 dash. Shall I write right? This is F2 dash, which is equals to F naught into bracket. This both are moving in the same direction, so it's a v minus of v naught divided by v. I hope this is clear. So now I am having the f1 dash, now I am having the f2 dash. Let's find out the bits frequency. This bits frequency could be given as this is equals to f1 dash minus of f2 dash, and this is equals to f naught by v into bracket v plus v naught minus of v minus of v naught. I hope this is clear. Sorry, plus v naught. I hope this is clear. So this v would be completely cancelled out, and this is f naught by v multiplied by twice of v naught. This is the bits frequency that we are going to receive. I hope this is clear. Is it clear? One more question that combine the concept of beats and Doppler. Yes, let's have a look. The question says that an observer is standing on railway platform. He heard a certain frequency of sound by train when train is very far away from the station. Call this f1, and another frequency f2 when train passes by him. When train passes by him. Find out beats frequency of this. How will you do this? Let's understood the situation. Let's say this is the observer, and this is the train who is playing a sound of frequency f naught, and it is moving in this direction with speed, let's say v, and after some time it will passes through this observer, and it will be now very far away. So again it will play a sound of f naught. Its speed will remain the same. What we are supposed to heard is when this at this location a sound will be played, it's an f1, and when this location sound will be played, it's an f2. So this is first my requirement is I need to find out the f1 and f2. How will I do this? So when I look for the f1, this f1 could be equals to, this is equals to f naught, observer is at rest, so this is equals to v upon v minus vs. And what about the f2, which is equals to f naught into bracket v upon v plus vs. I hope this is clear. So when I look for the bits frequency, this is equals to f1 minus of f2, and this should be is equals to f naught into bracket v upon v minus of vs minus of f naught upon v plus vs. So this is simply f naught into v into bracket v plus vs minus v plus vs divided by v square minus of v s square. This is the situation. So as this and this has gone, so this is equals to f naught into v into vs plus vs. This is equals to 2vs divided by v square minus vs square. So this is 2 into f naught into v into vs divided by v square minus of vs square. This can be calculated like this. I hope this is clear. Was it clear? Are you sure? Great. So now let's look at certain quick questions. A Doppler's effect is, yes, it's a wave phenomenon. Next, Doppler effect is applicable to sound waves. Yes, we have studied this time. Light waves, we will study this into the wave optics class 12. Radio waves, this is applicable but not on our syllabus. So this is applicable to all of the above. I hope this is clear. Great. So let's wind up the session over here. This was all about the Doppler effect. Please go through this very carefully. And this is a very important topic when we discuss this with respect to NEET examinations or JEE examinations. So please go through this very carefully. This is very essential topic for the competitive examination. Please go through this, go through the content, go through the lecture, and revise as many questions as possible, because there is a very high probability to be asked in the questions, to be asked in the examinations. As you will go through the previous year asked questions, you will find this. Thank you. Have a good day. Take care.